let's take a minute to get used to some of the terminology that we're going to be dealing with as we study algebra and we talk about simplifying algebraic expressions, and later on as we get into equations. The first word I want you to be familiar with is the word terms. Terms are always separated in a problem or in an expression or an equation by either plus or minus signs. In this particular example I've given you, we have three terms in this problem. The negative 5x is a term, the positive 3y is the second term, and the negative 2 would be the third term. Now you notice I'm leaving the sign that is in front of the term with it, even though the plus and the minus are also operations that are separating the terms. Next would be expression. When we say an algebraic expression, you need to know that it has no equal sign. It has multiple terms as x plus 11y plus 2, but there is not an equal sign. The difference in an expression and an equation is the equal sign. An equation has multiple terms also, but it has an equal sign. Therefore, it has two sides to the equation. You can think about the equal sign as splitting the equation into two parts. Side 1 is on the left and side 2 is on the right. Now, an equation, because it has the two sides, as we will see later when we start working with equations, allows us to do certain things that we cannot do when we have expressions. So the fact that the equal sign sets us up with two sides is very important, and you need to note that. Next would be the word variable. The variable is the unknown. The unknown, and it is inside a term, is usually represented, is always represented by letters. In other words, when we see negative 3x, the unknown part of that is the x. X represents a number in this particular expression or in this particular term. We don't know what that number is. That's why we have to represent it with something that we can find out the answer to later, the unknown or the letter x. The coefficient is the number that's multiplied times the variable. Now, our variables can get very complicated, as you see with this term where we have x squared, y to the fourth, z. Those are all multiplied times each other, but together they make up the variable for that term. The coefficient is 37. 37 is multiplied times the variable. It will be in front of the variable. When we talk about combining like terms, you need to note that this can only be done when the variables are identical. We can only combine terms that, for instance, have 3x and 4x, or 3x squared and 4x squared. Whatever the variable has with it, if it's an exponent or if it's another value, another part of a variable, as if we added a y, they would have to be identical before we could combine those like terms. Also, I want you to remember that the sign that is in front of the term stays with it. I said when I wrote it down, the sign stays with the term that follows the sign. So in this particular example, the negative sign in front of 2x stays with that term. The term is negative 2x. The positive in front of 4y stays with it. The term is a positive 4y. And the negative in front of the 1 stays with it. This term would be a negative 1. Now, when you're distributing multiplication, you'll note that that means you have a number or a term that's directly in front of a parentheses, and inside that parentheses we have one or more terms inside there. So what we do is that tells us we need to multiply. We need to multiply whatever's in front of the parentheses times everything, each term that's inside the parentheses. We always use the sign in front of the term when we do this multiplication. With this example, we would say a negative 4 times 2x. That would give us a negative 8x. And then we would multiply that same negative 4 times the next term, which is a negative 3. That's going to be a negative times a negative. Even number of negatives, it's going to be a positive 12. Now, the sign of our term just became the operation separating it. So that's okay. That's what we want to happen. Don't get confused between the signs of the terms and the operations. Sometimes they work together. Let's look at an example of combining terms. Example 1 says 8y plus 3y. Well, the variable y is exactly the same in both of those, so we can just add the coefficients. We can add the 8 and the 3 and have 11y. It's sort of like saying 8 apples plus 3 apples equals 11 apples. We don't know what y represents, but we know that it represents the exact same number in each one. That's why we can just add the coefficients when it tells us to add. Example 2 is subtraction, 7z minus 10z. Well, we know our variable is going to stay the same. It's going to be z. We're going to say 7 minus 10 will give us a negative 3. Remember, when we're doing addition and subtraction, we subtract the numbers and then we keep the sign of the larger one. And the 10, of course, was larger than 7. Example 3, we've got several terms that we can combine. Let's find the like terms. Start with 5y. I'm going to put a square around it, and I'm going to look for another y term that I can combine. Here's one, a positive 6y. I'm going to keep the sign with the term, the sign that's in front, so I know what I'm doing. I can say 5y, and since there's no sign in front of it, I assume it's positive. It is. 5y plus 6y gives me 11y. Now let's look for some other terms we can combine. I see I have a negative 7x, and I have a positive 8x. Those are like terms and can be combined. I can say negative 7 plus 8 would mean 8 minus 7, or just 1. A positive 1x is the same as plus x. And you can write a 1 in front of it if you want to, but most of the time in algebra, if there's a coefficient of a 1, we do not see it written. Lastly, I just have a plain number. It has no variable, so I can't combine it with anything else. I just have to bring it down and keep it. I ended up with 3 terms in my answer, 11y, a positive 1x, and a positive 2 plus 2. Okay, let's do a few more. Example 4 is multiplication, distribution, but there's only one term inside parentheses, so I'm going to multiply that 4 times the 4x, and I come up with 16x. Next, let's take a negative 4 and multiply it times both terms inside parentheses for number 5. Negative 4 times 3x would give me a negative 12x. Negative 4 times positive 7 would give me a negative 28. Remember your rules for multiplying and dividing negative numbers, or with negative numbers. An even number of negatives, we have a positive answer. Odd number of negatives, we have a negative answer. And since we only have one negative each time, these are both negative numbers. Next, in number 6, we look to see first inside the parentheses if we can do any simplification before we start distributing this outside 2 that we have to distribute. I look at my innermost parentheses and I don't have like terms. 7x plus 5 cannot be combined. So I go just outside and I see that I'm going to have to distribute a negative 3. I'm just going to write the rest of the problem down. And then I'm going to say a negative 3 times 7x gives me a negative 21x. Look how my negative just became my operation of subtraction between those two terms, which is what we wanted. And then I'm going to distribute that negative 3 times the positive 5, which would give me a negative 15. Once again, the sign became the operation. Now, inside my parentheses, do I have terms that can be combined? I think I do. I see a positive 4 and a negative 15. Let's fix that. I'm going to write it up here. I'm going to say 2 times is still outside the parentheses, but 4 minus 15 gives me a negative 11. Remember, when I'm subtracting and adding, I subtract the numbers and keep the sign of the larger. And then I say minus 21x is a term that I can't combine with anything else. I just have to remember to bring it down. So what's my final step here, or my next step? Distribute the 2. I'm going to multiply the 2 times each of the terms in parentheses. 2 times negative 11 will give me a negative 22. And 2 times a negative 21x is going to give me a negative 42x. Now take a look at your terms. Can anything else be done with those terms? I think not. I think we're pretty much finished distributing multiplication, and those two terms are not alike, so they cannot be combined. Take a look at number 7. Once again, we have to look at innermost parentheses. That would be our x plus 2. Not like terms, so we can't do anything. We're going to step right outside there and distribute that negative 4 that's in front. I'm just going to write everything else down so that I don't lose anything from the problem while I do that. So I write down negative 3 times 2x, and then I'm going to say negative 4 times x. That gives me a negative 4x. Then I say negative 4 times positive 2. That gives me a negative 8. Everything else in the problem, I just write down. Now, in this problem, I have to look inside the big parentheses and see if I can combine any of these terms. It looks like I can. 2x minus 4x, those are like terms. I'll leave my negative 3 out here. 2x minus 4x gives me a negative 2x. And then I look and see some more like terms, a negative 8 minus 3. That would be negative 11. For my next step, I can finally distribute my negative 3 because nothing in parentheses can be simplified. So I say negative 3 times negative 2x, positive 6x. And then I say negative 3 times negative 11 is a positive 33. My answer, 6x plus 33, is two terms not alike, so I cannot simplify them any farther. Next, example 8, more of the same. Inside parentheses, we can't do anything because we don't have like terms. We're going to distribute the 5 to both of those terms. Everything else in my problem, I'm just going to write it down. 8z, and I say 5 plus 6, and say times 6 is a positive 30, and I say 5 times z is a positive 5z. I bring down my plus 20. Let's find some terms and see if we can combine like terms now. I do have a positive 8z and a positive 5z. When I add those together, I'll have 13z. I also have a positive 30 and a positive 20. When I add those together, I will have plus 50. And the sign of my term, C, became my operation separated term. So I answer 13z plus 50. Example number 9, we need to distribute something. We have nothing that is alike inside parentheses, so we're going to distribute the numbers on the outside. But take a look at the first set of parentheses. What we have is a negative outside parentheses. What are they asking you to distribute? Well, they're really asking you to distribute a negative 1. So let's do that. We say negative 1 times 12b, and that gives me a negative 12b. And then we say negative 1 times positive 10. That gives me a negative 10. I can also distribute the positive 5 that's outside the parentheses for 3b minus 2 by saying 5 times 3b is a positive 15b, and 5 times negative 2 is a negative 10. Now we look for like terms. I see one. I have negative 12b and a positive 15b. Well, that would need to be subtracted and keep the sign of the larger. 15 minus 12 gives me 3b. And then I have a negative 10 and a negative 10. When I combine those, I add them and keep the sign, which is negative. I almost wrote it down as positive. So my answer is 3b minus 20. For example 10, let's do distribution once again because nothing inside parentheses can be simplified. For the first one, I say 3 times 5x is 15x, and I say 3 times 2 is a positive 6. For my second one, I say 2 times 3 is a positive 6x, and 2 times 1 is a positive 2. Next, look for like terms. 15x and a positive 6x would give me a positive 21x. And then I have a positive 6 and a positive 2. That gives me a positive 8. Now, although 21x is a positive term, I don't have to put a plus in front of it. I only have to put the plus in there if I want to separate it from another term, like I did with the positive 8.